Yes, I'll try to actually record this. Try not to sniffle or sneeze too much. Um, Last class I had a sneezing fit right in the middle. Got 7 of them. So here we go. Here's Microsoft Access, and I have just a database open, and we can see the different types of objects is what Access calls them. If I look tables, of course, from our understanding, that's at the conceptual schema. Queries will also be defined by the database administrators or designers, and also part of the conceptual schema. Forms are for the end users, and of course this is the external schema. And Access does give us a little bit of control over the physical schema, but not really, not in the sense of like a true Oracle database would. So we can look at a table. Let's look at a table here. And let's look at customers here. Okay. And now this is a data view. Again, end users should never be operating at the data view level. And I can take a look. Let's go to views instead. So let's look at design view. Okay. And now we can start to see of course, the field name, but the data type. But recall that I said the data type can be extended to actually have domain type specifications. You will see a key here, okay, or you see the key here, if I can get the arrow there, and it's representing that that first field is the primary key. The primary key uniquely identifies a record or entity, and that's what we need. No two records in a normalized database will be the same, or alternatively saying is they will be unique. And I see all kinds of extra information here. I can format field size. Field size is important, okay? And we do have 2 different choices. I can have a fixed field size or I can have a variable. And they do impact performance. If everything is fixed, I can work with offsets. If every field is 10 characters, so to speak, I know the 5th field starts here. I know the 5th field into the 5th record starts here. As soon as we move to variable fields, I don't have that anymore, and I actually have to really maintain better addressing or indexes. Now, field size, we should limit it to as small as possible. Something came out in the early 2000s known as the SQL injection attack. And what this really was with web forms. The web form, of course, you're inputting your credit card information, username, whatever. It's on a form on a web. And of course, this gets passed back to that middle logic in that end tier architecture. It's going to go right through the firewall. Why? Because that server, Amazon, sent you out that form so you could make that purchase. And as long as you've put something into each field that it understands, it's expecting it, stateful packet inspection. So it's passing right through the firewall. At which point it's going to take out that text field, essentially, and put it right into an SQL statement. So you're trying to get your past orders or whatever. It's going to take your name, all your account information, and just package it into an SQL statement and present it to the database. Well, someone learned that they could put, say, the Oracle escape sequence in if that field was not restricted. If that field was 255 characters, I have more than enough room to put an Oracle escape sequence and actually add my own SQL statement and just start accessing the core database right through the firewall because it wasn't locked down to prevent SQL injection attacks. And there are various methods to overcome that. There's still a lot of databases out there that do not really test and prevent this. So there's still a lot of unsecured databases out there. So you can see, I can have validation rules. So again, I presented from the integration hierarchy, okay? Data, infrastructure, business process. And at the data layer, if everything is in the same database, the same format, everything becomes easier. Okay, so databases are at the core of management information systems. They're also at the core of my web application or my web server. In my database, I may have product manuals, warranty information, all of these things. If I have the same database in both my web and for my MIS, obviously I'm going to be able to present things to the web very easily. Otherwise, I'm updating two databases. Okay, I'm updating one database, and then I have to push that information with middleware or whatever over to my web database whenever I update a warranty or service agreement or product manual, whatever. Okay. So, validation rules and text, whether they're required or not. And again, if I do this at the core database level, I can actually percolate it up to my web. Emails required. Don't move forward. Transaction. All or nothing at all. Okay. Taking a look at another one, categories. Interesting here, picture. It's a bitmap image. Okay, and I can take a look at the view. Okay, so I have a picture. Okay, and again, this is going beyond your typical type definition that you'd see in Java, int x, short, long, string, something like that. I now can actually have an image, an MP3, a video. So again, percolating this up through, here I'm working from a kind of a business MIS perspective. If it's also going to the web, of course, if you put out a PDF, an AVI, an MP3, the browser is going to recognize it and can act on it intuitively. Play the MP3, show the AVI, show the DivX. Okay? What we're doing is we're streamlining management. Less work we have to do. I just keep the database consistent. That's my focus. I know that everything, the architectural layers above it, work correctly. So again, another reason for having this architecture.
Is the architecture access?
Well, no. In this case, the application, the database is access. When I used the word architecture, I was actually talking about like the N-tier architecture of the web, the database core, the middle logic, for us PHP quite often, and then the Apache web server. So that's the three-level architecture. I can talk about a database architecture from that abstract level, physical, conceptual, external. So I probably should have been more specific on which architecture I was referring to. When I look at this architecture, what am I using is Access and Windows. So that's really what I'm talking about here. Now let's take a look, one last thing here for database tools. Let's look at the relationships. Because this really drives home why we need, and really the end result of a database normalization and database design here. Let's think, though, first, what we have from a business process perspective. Customers placing orders, and, of course, their order details. Think about if we didn't have this normalized form. What would I do? I'd take the customer information. I would take their order, the date it was, whatever, and the order details. Now, constraining this into a computing system, well, I have to make some kind of assumptions. What if the person is ordering one item? Okay, I could do that. What if they want to order 5? Do I create 5 entries? Customer information, order information, the order detail, 1 item. Customer information, order, same order number, item 2. So you can see I'm just adding redundant information over and over. The customer's order, the customer's information. Okay, well, what if I think, well, maybe I should leave space for them to order 5 or 10 items. Okay, now they order 1 item. I'm now wasting space, storing nothing for the extra 4 items. And again, if I'm saving space for 5 items, what happens if they want to order 6? Then again, I'm right back to that. I have two separate lines. So the flat file system doesn't work. Okay, it's not efficient, it's not effective. So looking at this, let's look at the customers table here. I see my key, and again, this is the primary key. Every table or entity will have a primary key that allows us to uniquely identify it. So no 2 rows or records within a table are going to be the same. They're unique. We're also seeing a cardinality. Okay? So I have a one-to-one possible. The possible cardinalities are one-to-one, one-to-many, and of course many-to-one. So a customer can make many orders. Yep, they could order in September, October, November, December. So this model accommodates that. And with respect to each order, they may order one item, they may order 1,000. So I can have orders that reference order details. So I have a one-to-many from customer to orders and a one-to-many to order to details. So that demonstrates primary keys, but note that a table can have, and almost, in many cases has to have, foreign keys. A foreign key in a table will reference, remember what I said, reference is an address, or relate to a primary key in another table. And that's what I found, the textbook, the way it presented it, it's correct, but the first 2-3 times I read it, it confused me. I questioned, is this right? Are they? And I had to really read through, and I said, okay, it's correct, but the way they present it, it's not straightforward. Okay, every table has a primary key. To relate a table to another table, the first table is going to use a foreign key in its table to relate to a primary key in another table. And that makes sense. Primary keys uniquely identify records. So if I want to uniquely identify something in another table, I have a foreign key that relates to its primary key. Okay? Now there are other things here. We'll get into referential integrity and constraints. But here we can see that, going back to products, product ID is the primary key. Okay? So linking up the two tables. And here I have the supplier ID is a foreign key here and a primary key here. Category ID is a foreign key here and a primary key here. Okay, so, and I think that's all I have for that.